हेलो दोस्तों, अगर मेरे पास एक सिंपल पेंडुलम है और वो सिंपल पेंडुलम को मैं ऑसिलेशन देते वक्त लिफ्ट में ट्रेवलिंग कर रहा हूँ, यानी मेरी लिफ्ट ऊपर भी जा रही है और नीचे भी आ रही है और उसके साथ में इसको ऑब्जर्व भी कर रहा हूँ, तो क्या कुछ चेंजेस हो सकते हैं पीरियड में सिंपल पेंडुलम के? स्वयं विचार कीजिएगा। So welcome to the online session of Spectrum Academy. This is the Indrajit Shriwastav. Now today we will see what exactly the motion of simple pendulum in the lift traveling. So in the last session we have studied the simple pendulum performs angular RSHM. Now what will be its period, what are the things, what are the restoring torque, that we have seen in the last lecture. So the period of the simple pendulum is given by t equals to 2 pi under root of L upon g, where L is the length of the pendulum and g is the acceleration due to gravity. But अगर यही पेंडुलम मैं एक लिफ्ट में लेकर जा रहा हूँ तो उस पीरियड पर कुछ चेंजेस होंगे, या तो होंगे तो कितने वैल्यू से चेंजेस हो गए, अगर नहीं हो रहे हैं कुछ चेंजेस तो क्या वैल्यू से चेंजेस नहीं हो रहे हैं, अगर वो सेम पीरियड रहने वाला है तो क्यों रह रहा है, इस टॉपिक पे आज हम चर्चा करने वाले हैं. सो कंसिडर द अ लिफ्ट विच इज मूविंग अपवर्ड्स. ये ऊपर जा रही है फ्लोर 2 पर. सो लिफ्ट इज मूविंग अपवर्ड विथ सम एक्सेलरेशन, राइट? And we have a simple pendulum which is in the lift. Now lift is going upward and at the same time the simple pendulum is doing its revolution, that means is performing the angular simple harmonic motion in the lift. Now we have to determine the period of this pendulum in the lift, and the lift is moving upwards. Now the lift is moving upward, so the lift must have some acceleration. So let us consider the acceleration of the lift is a. That means the lift is moving with acceleration a in the upward direction. Then what are the forces on this pendulum? Now if the lift is moving upwards, now if the lift is moving upwards with acceleration a, then the forces on this simple pendulum are, the first force is gravitational force which is acting downwards of magnitude mg, and the lift is moving upward with acceleration a, so there is some pseudo force acting on this bob of mass m in opposite direction of the real force, that means in the downward direction with magnitude mass into acceleration. So there are the two forces, and the other forces also the tension, and that's all the things which we have seen in the last session. But the main forces on the bob are, the first one is mg, so here mg force, and the second force is mass into acceleration which is the pseudo force. So the pseudo force also acts in the downward direction. So the total force in the downward direction are, so F equals to mg plus some pseudo force. Pseudo force क्या होता है? Pseudo force अगर कुछ एक्सेलरेशन हम दे रहे हैं, रियल एक्सेलरेशन, उसके अपोजिट में कुछ एक्सेलरेशन हमें मिलता है तो वो उसे हम कहते हैं सम pseudo force. अगर मैं कार में बैठा हूं और कार को एक्सेलरेट कर रहा हूं इन फॉरवर्ड डायरेक्शन, फिर हम क्या देखते हैं, हम पीछे जाते हैं, सो दिस इज द सम pseudo force. अब acceleration is in this direction but we experience the force in that opposite direction. So यहां पर रियल फोर्स है ऊपर की ओर, लिफ्ट जा रही ऊपर, एक्सेलरेशन सम ऊपर, लेकिन ये बॉब कुछ सूडो फोर्स एक्सपीरियंस करेगा इस रियल फोर्स के अपोजिट डायरेक्शन में, मींस नीचे वाले डायरेक्शन में. मैग्नीट्यूड होगा मास इनटू एक्सेलरेशन एंड द डायरेक्शन इज डाउनवर्ड्स. So the total force is F equals to mg plus pseudo force is m into a. So the total force is mg plus a. But this is F total. But we can write according to the Newton's law, F total is total mass into total acceleration equals to m into g plus a. Comparing the things, the total acceleration will be given as g plus a. So total acceleration is given as g plus a. In what condition? The lift is moving upwards with acceleration a. Up total acceleration acting on the bob is not only g plus, but there is addition of some pseudo acceleration a. So g plus a is the resultant acceleration acting on the bob. Now we know that at equals to g plus a. So we have this. So the total acceleration on the bob is g plus a. But in the last session we have seen that the period of simple pendulum is simply given by 2 pi under root of length upon g. अब वो सिंपल पेंडुलम कहा था, वो सिंपल पेंडुलम इन रेगुलर एयर मोड, इन एयर मीडियम, जहां पर एक ही एक्सेलरेशन होता है इग्नोरिंग द एयर रेजिस्टेंस एंड ऑल द थिंग्स. सो एक ही एक्सेलरेशन होता है g. अब इसे हम जनरलाइज कर सकते हैं. So we can generalize the things. This can be written as 2 pi under root of L upon total resultant acceleration. वहां पर total acceleration just g था. अब उसे जनरलाइज किया तो टोटल एक्सेलरेशन लिख सकते. लेकिन इस केस में हमें टोटल रिजल्टेंट एक्सेलरेशन, इफेक्टिव एक्सेलरेशन, दिस इज नथिंग बट इफेक्टिव एक्सेलरेशन. अब यहां पर इफेक्टिव एक्सेलरेशन हमें दिख रहा है g plus a. Then the period of the simple pendulum in this case is L upon g plus a. So if your pendulum is in the lift and the lift is moving upwards with some acceleration a, then the period of the simple pendulum is given by capital T equals to 2 pi under root of L upon effective acceleration, and this effective acceleration is g plus a. But in regular mode the acceleration is t equals to 2 pi under root of L upon g. Now which period is greater? Now here g, here denominator is small and here denominator is high. Denominator high, so period is low, and the denominator is low, so period is high. So अगर हम पेंडुलम को लिफ्ट में लेकर जाते हैं एंड द लिफ्ट इज मूविंग अपवर्ड्स विद सम एक्सेलरेशन, तो हमें क्या दिखता है, जो उसका रेगुलर पीरियड था t, वो कम हो जाता है विथ वैल्यू 2 पाई अंडर रूट ऑफ L g प्लस a. मींस अगर वो उसका पीरियड एयर में कुछ है तो लिफ्ट में जाने के बाद एंड लिफ्ट इज मूविंग अपवर्ड्स, पीरियड उसका कम होने वाला है. पीरियड इंक्रीज नहीं होगा, पीरियड डिक्रीज होगा. सो द पीरियड ऑफ सिंपल पेंडुलम डिक्रीजेस इफ द पेंडुलम is moving in the lift and the lift is moving upwards with some acceleration a. Now what will be the things if the pendulum is in the lift and the lift is moving downwards with acceleration a? So moving ahead for the next case, so if our lift is moving downwards, so अब ये lift down 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 जा रही है with some acceleration. Suppose its acceleration is a, moving downwards. So अब फिर से इस बॉब पर एक फोर्स लग रहा है इधर mg. द सेकंड फोर्स, अब लिफ्ट नीचे की ओर जा रही है, रियल फोर्स a. सो बॉब एक्सपीरियंस करेगा सूडो फोर्स विथ अपवर्ड डायरेक्शन m into a, राइट? सो m into a. सो यहां पर टोटल फोर्स हम लिख सकते हैं F टोटल इक्वल्स टू mg प्लस m इंटू माइनस a, क्योंकि एक्सेलरेशन अब अपोजिट डायरेक्शन में है. So we can write his mg minus ma, so that mg minus a, and the total force is m into total acceleration. M get cancelled. So the resultant effective acceleration for the bob of the pendulum in the lift moving downwards with acceleration a. So the effective acceleration is g minus a. So g minus a is the acceleration. So the acceleration is g minus a. So we can write the period here. So t equals to 2 pi under root of L upon total resultant acceleration L upon 80. So equals to 2 pi under root L g minus a is the resultant period of the bob of the simple pendulum in the lift moving downwards. So the regular period T regular is given as, we know that, 2 pi under root of L upon g, and the T in the lift moving downwards is given by 2 pi under root of L upon g minus a. We can see here T and G accelerations are inversely proportional. T and G are inversely proportional. Now, this is reducing denominator. So, T in the lift moving downwards is high, and this is G. So, here period is low with respect to this period. So, we can see that the period of simple pendulum is increased, or we can say the period of simple pendulum increases if the simple pendulum is in the lift and the lift is moving downwards. So these are the case if we take the simple pendulum in the lift and the lift is moving upwards, then the period decreases, and we take same simple pendulum in the lift and the lift is moving downwards, then the period of simple pendulum increases. So these are the two things. In the next session we will see what if the simple pendulum is in the moving car and the simple pendulum is in the fluid, then what will be the changes in its period. That will be very much interesting topic. Thank you.